Well, thank you guys for coming tonight. We're trying something a little bit new. First of all, I'm Matt McCauley. I am the vice president of the Kirkland Heritage Society. The president, Chris, is in the background turning the knobs and buttons and making this whole thing work for us. So he's going to be a little bit lower key. Also on the panel tonight, we've got Kent Sullivan, who is a longtime railroad researcher. Uh, he and I have been working on this project for 9 years or so now, probably doing research. Other members of our team that came on shortly thereafter, we've got Mike Donnelly, who's going to be talking a lot tonight. Mike is a retired engineer and very avid railroad modeler. And I would say when we talk about railroad modeling, maybe the first thing that comes to mind is that Christmas with the Lionel in a circle around the Christmas tree, or if you're Gen X, maybe the Tycho HO gauge figure eight. That's all great stuff, and it's really important to include kids in model railroading. But at the adult level these days, model railroading has become incredibly sophisticated. And so Mike has been able to take some of the tools used in precise model railroading to apply them to our study of what would have been at the Kirk Steel Mill up on Rose Hill. So he's going to explain all that in some detail, but I wanted to just give you a little bit of background here. So we're getting kind of a combination of super high modeling skill along with the engineering and CAD skills. So it's some really fantastic stuff. I've never seen anybody do anything like this before. And so we're really excited to have it here as this kind of debut for this Kirkland question. And then last and certainly not least, Sandy Middleton is Peter Kirk's biographer. She is the author of The Pioneering Life of Peter Kirk. And I have one copy that I write in, and I have a second copy that I give away to people because as I've gotten old, I've turned into one of the guys that hands out books to people. So I encourage you to get two copies, one to write in and one to give away to your friends and family. So she has done some amazing research on not only Peter Kirk, her second great grandfather, I might add, but a lot of the background on a lot of the industrial processes that led Kirk to the point that brought us here, that brought him over to the United States and putting that all together. So we've really got kind of an incredible team. And as I'm holding up books, I should point out Kirkland Heritage Society, we wanted to kind of expand our reach as far as meetings. And it's not always convenient, particularly in the winter months, for everybody to get out into the dark and come on down to Heritage Hall. So we thought we would try to expand things during some of the times that we don't normally have an in-person meeting to bring some of these more in-depth kinds of Zoom sessions to you. If you're not a member of the Kirkland Heritage Society, I encourage you to join. One of the perks of benefits of membership, one of the perks is you get a newsletter that we put out that is not only just the typical historical society news and who did what, but there is a lot of good historical information presented in this. Our collections director, Louita Hawkinson, has been editing this for years, and she does a really outstanding job. So frankly, and you get this snail mail. You can get it PDF too, but you end up with this in your hand when it comes to your mailbox. So it's a lot of fun. This alone is pretty much worth the membership. And while we're at it, for those of you that didn't know, Chris Neer's grandfather is the late Bob Neer, who is past mayor, longtime city councilman, going back to Houghton Council from the old town of Houghton. And he put together some years back before his passing, probably the best ever municipal history on Kirkland. Kirkland in the modern era, basically from the late 1950s on up into the early 2000s. These are available for sale down at KHS. This is an incredible book. This is another one I give away to anybody that makes any kind of noise about running for city council. I give them a copy of this book. It's really fantastic stuff. So I wanted to plug that as well. Oh, as long as I'm plugging books. I wrote this one about 15 years ago. It's available on Amazon. And then the Arcadia book on Kirkland, I did too. And that features photos from the Kirkland Heritage Society collection, just in case you're wondering who I was. So with all the book pitching out of the way, I thought what we would do is, after I've introduced everybody, is kind of hand things over to Kent, and he's going to sort of set the stage and sort of explain where we're going to go by this. But essentially what we're doing tonight is taking a look at what would have been built in Kirkland had the Peter Kirk, Lee Hunt, Great Western Iron and Steel Company venture been successful. So take it away, Kent.
All right, thanks everyone, and thanks Matt, and hello everyone. Could someone or a couple of someone's just type a hello into the chat so we make sure that it's enabled properly? Because we're going to be taking questions and things from you all that way later. Okay, good. Thank you, Jack. So we know chat is enabled. All right. So let me go ahead and share. We're going to start with just a couple of slides, and then we're going to switch over to the CAD model. All right, so again, this is presentation about the Kirkland Steel Mill, and Matt already introduced the team, and Mike Intlekofer has been kind of a contributing member as well, and I see him in the audience tonight. Mike, I'm glad you could make it. And so briefly, I'm going to set some context from where we were when we did part one back in October, which, by the way, October, that has been recorded and it's available on the KHS YouTube. We have sent that link out in email and several places on Facebook, and I think it'll probably show up in the next Blackberry Preserves newsletter. So the entire presentation, parts 1 and 2, have these sections, and part 1 we covered up through 1892 or the middle. So tonight we're going to talk about the collapse, how things didn't go to completion, and then our very thoughtful, years-long collaboration to speculate what the finished mill would have looked like and how steel mills work in general, or how they did work in the 19th century. So to review then, in phase 1, we talked about what we call our phase 1. We don't know what the iron and steel folks called it, but we gave it a name. It was the preparation to build the whole mill, and it's really a bootstrap. If you joined us for part 1 or you looked at the video, it was building a small amount of buildings with a small amount of equipment that could then in turn build everything else, build the buildings, build the machinery, that sort of stuff. And we reviewed what the photo evidence tells us to kind of give you a flavor of what you were going to be seeing, where all the photos came from, the maps, diagrams, things like that. And Mike walked you through the CAD model up through the end of phase 1, which looks roughly like this. Again, we go into a lot more detail about how all this works in the part 1 video. And then tonight, we're going to talk about the intentions. As best we can tell from all the sources, lots and lots of triangulation, talking to experts, looking in books, which Michael tells us about those. What our best guesses are for what we call phases 2 through 5 in the CAD model. It's pretty clear to us that the mill wasn't going to be all built at once, and so that's why there's more than just a phase 2. There's a few different pieces to what was intended. And so he'll be showing the fully built out CAD model, which kind of looks like this. And of course, it doesn't make any sense to just show you all like that, but it's really just how different it was from this little bit here to go to this then. There was a lot that was going to be built. And as a reminder, this is a 100-acre site we're talking about. So there was a lot of space, and it was going to be a really big endeavor. Okay, so that's all I really wanted to do at this point, was to just kind of introduce, set some context, and now I'm going to hand it over to Mike. Mike, you're muted. Still muted. Okay, fingers up. All right. Hello, 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 hello. Hello. Looks like Mike's having some technical difficulties here. It was all fine a couple of minutes ago.
Okay, can you hear me now?
I sure can.
I
Yeah.
was getting a note that said the host was not allowing participants to unmute themselves.
Ah, okay. Well,
I don't know, I was trying to send a note through chat about that, but somebody
yeah.
figured it out.
All right, here we go.
Okay. So we're going to start. Okay, how do I get rid of this note in the middle of my screen? And I have to forgive me a minute. I need to move some of this stuff out of the way so that I can manipulate the program. Um, so for those of you who didn't see this before, Um, this is a model railroad planning software. It happens that I just happen to have it. Is mostly. I think you probably could have done this with any random CAD program. But anyway, so this is actually drawn full size, and I can bring in pictures and all sorts of things, which we will be doing. Um, we talked about how we got to this point where we show where the mill was. There were a couple of things in the last presentation we left out, and I'm going to try to catch up on them now, simply to try to do it. Um, so one of the things that we always had tried to do, and in fact we showed this when we developed where the mill was located, is trying to use photo evidence to give us clues for where things should have been. And one of the clues is a set of pictures here that came, and I can't, or Matt, you'll have to say where we got these from because I don't know, but um, this is part of the Birken Ferraris plat. It's lot number 2 in this one area. And the interesting thing about this is that it shows a bank in the back here. And in fact, there's a building, a house, I guess, on a bank with a bunch of stairs to it. Now, what we'll do is I'm going to come back and show you where this is in real space. How come I keep going to the back? So this is the lot number 2 that they're talking about right here. And I'm going to take away the lot lines for the moment. And I'm going to bring in a picture. I've got a bunch of different pictures of this, and then I had to, the picture quality gets better the more I zoom in on it. And I'm also going to hide the mill because the mill kind of clouds things a little bit. And you can see in this that here's a house, and here's a house, and here's a bunch of diagonal lines that definitely appear to be man-made. And now that you can see those, that's what I wanted to show you. I'm going to turn the mill back on. And you can see that they're somewhat coincident with where the bunkers are. So this was another little bit of proof for that we got this stuff located in about the right place. Now, I wouldn't get too excited when you see that the lines don't exactly line up because that's just the nature of the beast trying to bring in all the different pictures of things. And then the other thing we wanted to show this is just, some more evidence that we had found for where the mill was. And then the other thing I wanted to do that we didn't do before was show the picture. Okay, so here's essentially a Google Earth picture of the whole area that this is encompassed. So the railroad is over here just to the west of where 405 is. This is Costco. That's Petco. And this is, there's a bunch of industries here. And so I could tell you that this is 8722 122nd Avenue. So that's the address of the mill site for anybody that wants to go look at the buildings. So like I said, we just wanted to kind of catch up on a couple of those things, and we kind of forgot to show them at the end of the last presentation. So this part was imagining what the mill would look like and where it would be located. Now we have a bunch of different references of information for this. And I'm going to have to give you a little bit of not history, but so one of the references is a pamphlet, a promotional pamphlet called Kirkland and Lake Washington, published by Axel Anderson in 1891, May. And so when I refer to Anderson, I'm referring to that particular document. Now there's very few pictures of what this Rose Hill site would have looked like. Um, so Anderson has got basically, written descriptions of things. Um, another thing I'm going to make a mention about, since there's potentially some confusion, is the term Moss Bay. Um, so there's a Moss Bay in Kirkland, but that's not the one I'm talking about. When I refer to that, I'm going to be referring to Peter Kirk's Moss Bay Iron Works in England. So when I say Moss Bay, that's what I mean, not the Kirkland feature. So anyway, we were looking at where all this stuff is, and we only have a few clues, and one of them is from Anderson. And we'll have to get into this in a little bit more detail when we look at the downtown mill. Okay. And so Anderson has this quote: "Behind the trestle were being constructed 200 coke ovens, which will make enough coke for one of the large blast furnaces." And so when he says back of the trestles, this is the bunkers here, and this are all of the trestle works. So when he says the coke ovens, that's in this area. Now, I'll explain what coke ovens do a little bit later, but basically he's saying that there's something in this space. The next place that talks about anything, and we talked about this a little bit, is the Sanborn Insurance Company map. They frequently use publish maps. And here's the mill site. You can see right here's the bunkers, the foundry, the machine shop, the pattern shop. And there's a bunch of words right here, and it says blast furnaces go here. So when I come back to my map, that spot is right here. And so what that leaves us is that the rest of the mill must have been over in this space here somewhere, orientated in some fashion. And what I can do is I can show you the 19, actually it's okay. So this is simply because, oh, hang on. Okay, so here's your steel mill. This background is the 1936 aerial photography. And mostly I've used it because being black and white, it's not as distracting as the color. And in this particular case, we also, and this is what I'd wanted to show, is there are some contour lines shown on here. And so pretty clear that the contours go along sort of parallel to this track right here. And that would be the best way to orientate the rest of the mill, simply because it reduces the amount of grading. And so we have that as the rest of the mill then is in this space and probably orientated northeast southwest. But we don't have a lot of pictures. We don't have any pictures or like this, like a map of this the mill site here. We have two pictures and some words in the Anderson pamphlet. And we didn't know what steel mills looked like. And so what we did is we engaged a bunch of people. It should be the next bunch of stuff here. Oh, no. Uh-oh. I apologize. My picture file went corrupt on me the other day, and I had to rebuild it, and apparently I didn't rebuild the stuff. What I did is I showed copies of the covers of several books that we looked at. One was the History, Making, and Modeling of Steel Mills by a guy named Dean Freitag. Dean is part of a model railroading community, and they have a whole special interest group on modeling steel mills. And since Kent and I were both model railroaders, we kind of engaged that community. Um, and there's also another book by name Bernard Kempinski. And then there's another book called Bessemer Steel by a man named Philip Bagley. And that is specifically about Peter Kirk's English Moss Bay plant and the making of steel there. And then we also talked to a couple of people, Kevin Tully and Doug Geiger, who also the group, the modeling group. We talked to a man named Jim Swinkendorf, who was actually an engineer for the Elgin and Joliet Railroad, I think, back in Indiana, and he worked he worked as a train master at the steel mills. So these are all different people and sources that we used. And so I apologize for not getting that back in my model after it went corrupt on me. So anyway, as far as pictures go, this picture is in the Anderson pamphlet, and that was published in May of 1891 before there was any steel milled in here. And it shows basically the buildings that were built. So here's your foundry, there's the machine shop, the blacksmith shop, the pattern shop. These are the bunkers, and then a sawmill is here. And it also shows some track along here. And this is kind of an interesting picture um, because this is fairly accurately represented what you can see in these buildings. It's not an accurate representation of the sawmill, which is kind of funny because it existed at the time. And then in the back behind the bunkers, it shows a bunch of buildings. Presumably, that's the rest of the steel mill, except that by Anderson's own writing, that's where the coke ovens are. So this steel mill couldn't have been back there. So it's kind of an odd duck for a picture. And then it shows this track in here. It took us a while to figure out what this track might have been because it wasn't part of the railroad as we knew it. I think we finally figured out that this is probably going from the brick plant to the rest of the steel mill. And so that when they made bricks for the coke ovens and for the furnaces and stuff, they could transport it. But this doesn't help us much because it doesn't show anything about what the rest of the mill really would have looked like. This is pretty much what it looked like when they finished building what they built. And then this book was from the King's Handbook of the United States. Now, Amos King, back in those days, produced these books, and rather than being like a who's who, it's like a country by country, and in the case of the United States, state by state, what's going on and what's happening in the state. And so he had a few paragraphs and this picture of the Great Western Iron and Steel Company when he was talking about Washington State. And so here's a nice, interesting picture. We didn't know what to make of it to start with. We know from Anderson there were supposed to be 4 blast furnaces, and this was a blast furnace here. They only show one of them. This is a tower for bringing material up to the top of the blast furnace. And these 3 things in the background are stoves where they make the hot air to run the blast furnace. And so it's kind of funny because this picture is only showing a quarter of the blast furnaces that were planned. And then again, we didn't really know what these buildings were. So to start with, it was just kind of, oh, okay, that's interesting. Although we could figure out from here where it might have looked from. So if you put the camera, or you want to call it the camera, the viewpoint for that picture is over here somewhere. The blast furnaces are back here, and all this stuff would have been in here, which is perhaps further confirmation that this is maybe where the rest of the mill was. Okay. So we don't have any, like I say, we don't have any pictures here, but we do have some help in the form of plat map. And this is actually a tracing off the plat map. If just to prove that I actually have them in here, I can, come on. I have to apologize, but I do have to manipulate the model to make all this stuff work. So here's your actual plat map, and then I traced over it simply because it made it easier to read. So the plat map shows where the steel mill would have been, or where they originally planned to have it. And I think we explained all this in the part one presentation, that the original plan was to build the mill down here near the lake. And actually, maybe the picture does help with that, because you can actually see the lake is over here. So it gives us some clue for what they might have been planning, although this is somewhat incomplete. But what we're going to do with it to start with is explain what all the pieces of a steel mill are, and then explain some differences between what's shown here and what Anderson described. So, for example, in the Anderson pamphlet, they said that the mill was going to be built in halves, and each half was going to be the mirror image of the other. And when you look at this, it's obviously clearly there's not two halves of anything here. So it's possible that when they moved from this location up to the top of the hill, that they changed the scope of the project a little bit, but really don't know that. And the original reason this didn't happen, among other things, was that the railroad objected to the grade. And so this one shows the railroad coming in from the north here. And this grade in here is like 4 or 5%. And then if you actually were going to come over here to the other mill site, going from here to here is more like 6%. And with the steam engines of the day, functionally, they could bring one loaded car up or down the hill, or up the hill especially. And so they objected to that. But what's handy about this, at least, even though they never built this, like I say, was we can look at some of the things that they did. And so we'll start with these. So the railroad comes in here and drops off raw material at bunkers. And the bunkers are nothing more than a set of bins that hold whatever the raw material is. In this case, it's either iron ore, limestone, or coke. Now, coke is a product that's made from coal, a special kind of coal that has the right impurities and things in it. And those are all used to make, those are the main things used to make steel. And they're brought in here. Now, one of the things that's missing from this picture is where they make the coke. Now, remember from Anderson, he said the coke ovens were on the other side of the bunkers. Well, there's nothing in here that shows anything where the coke ovens were meant to be, whether they're here or whatever. So we have these, and these are blast furnaces. And there's 4 of them, which is interesting because both the mill up on the hill and Rose Hill described by Anderson and this picture both have 4 blast furnaces. I am going to hide this, I guess. And then these little round circles are presumably the stoves. The thing that's funny about that is that Seattle PI had an article about the steel mill, and they talked about the blast furnaces being 18 feet in diameter and the stoves being 26 feet in diameter. And these guys are nowhere near that big. But so I don't know if maybe it was just drawn this way kind of to cartoon stuff in, or if they were just smaller at the time. I don't know. But so now the way this works is this is your blast furnace. Essentially, it's a big cylinder, tapers a little bit toward the top, and you load the raw material into it in layers. The first layer is coke, the next layer is iron ore, the next layer is limestone. And then you repeat the layers. So it's like when you load the furnace up, it's like a giant parfait, if you want to think of it that way, all the way to the top. And the reason they call it a blast furnace is because they blast hot air into the area where all the coke is being burned. So the coke is the fuel. It burns very hot, it burns very clean, which is why they use it as opposed to regular coal. And so to provide the air blast, they have a boiler over here and a steam engine that runs a blower. that takes and blows the hot air into the blast furnace. Now the air is introduced down at the bottom, and it's actually hot enough that it can ignite the coke. They don't have to have a flame or anything to do with the temperature. The hot air does it. So as the coke burns, then it melts the iron. The limestone combines with impurities in the iron and helps take them out of the iron. And then as the iron melts, it drips into the bottom and collects. So the bottom of the blast furnace is called a hearth. And they have a couple of places in there where they can tap the liquid iron off. And then the limestone, when it combines with the impurities, it creates what's referred to as slag. And that's also can be drawn off at the bottom. So for like a ton and a half of iron ore, you get a ton of iron and a half a ton of slag. So, and then what happens is as the coke burns and melts the iron, the level inside the blast furnace slowly drops, and then they have a lift system that brings more material back up to the top, and essentially they just keep refilling it as they go. And once they fire off a blast furnace, it might not stop running for anywhere between 7 and 10 years. It's kind of interesting. But once they accumulate enough material and melted iron in the bottom, then they draw it off and put it into a ladle car. And so here's the tracks where the ladle cars are. We never did figure out what these sort of angled areas are. So I wish I could explain that for you, but I can't. But the iron ore anyway is put off into the ladle and then taken down from the smelting works, which is what they call this area, down to the steel works. Now, this whole area is essentially a valley. So this is the mill is in the bottom of the valley. The town is going up the hill on one side, and the blast furnaces and whatnot are on the hill on the other side of the valley. And so this is simply a series of switchbacks to get down to the level of the rest of the mill. Now, what comes out of the furnace is molten iron. It is not steel. Because it's burned with the carbon from the burning of the carbon with the coke, the steel tends to pick up too much carbon to be called steel. And so that comes over here. And we believe the plan was to use the Bessemer process to make the steel, which I'm going to get into the explanation of in a minute. And so there's the Bessemer converters, and we believe that they're in this building. It doesn't look like that. Okay, I've got some pictures here to show you. So there's no detail here in the middle of this building, but we do have some from Peter Kirk's book. This is also, I'll show you this too. This is a picture of the Peter Kirk's Moss Bay Works in England, and it's very similar to what you saw in the downtown. And that is that here's a blast furnace with some stoves behind it, and then train tracks coming in to carry away all the molten material. And this ends up being consistent with the Moss Bay Mill, the downtown mill. And so when we look at the mill we're going to Imagineer up on the hill in Rose Hill, we imagine that it's going to look a lot like what these guys do. Now, inside that Bessemer building, this is a better detail. And I have to give courtesy to Richard Beyer. He is the publisher of the Bessemer Steel book that Mr. Phil Bagley wrote. And he gave us permission to use the pictures. And in fact, he provided this one independent of the book, which was nice because it's actually more detailed than the one in the book. But so here's the Bessemer converters here. This is where they actually turn the iron into steel. And it kind of looks like a pineapple in a way. And it's hinged on a trunnion in the middle. And that's what these pictures kind of help you see. So you can see here it's rotated up, here it's rotated down. And so what they would do is they'll rotate it back, and that ladle car from the from the blast furnaces comes in here, and they pour the ladle full of molten iron into the Bessemer converter. And then they turn on there's air jets in the bottom here, and they turn the air jets on, and then they tip it up. And what happens here is that the air jets, the oxygen in the air that they introduce, burns off the carbon, and it oxidizes any other impurities in there. And so if you're familiar with fireworks, everyone's a different color. Well, that's kind of what happens here is depending on what the impurities are, you get all kinds of multicolored sparks shoot out the end. And as it burns the carbon off, um, in the presence of iron, it favors making carbon monoxide. If you just burned carbon in air, you get carbon dioxide. And so carbon monoxide is still flammable and it burns as it comes out the top here. And so this ends up being a pretty dramatic looking thing, I guess, because you get all these multicolored sparks shooting on. And then when the main part of the carbon is burning off, you got a 30-foot long flame coming out of the top of this thing. But when they're done, basically you've burned all the impurities out and functionally you have pure iron in here. It's still also not steel because there's alloying elements that they have to add in. So what they do is they'll tip it back to the loading position and pour in some alloying elements, and typically mixed with some more molten iron. And that gives it the right amount of carbon and the right amount of other material. In this case, they're making railroad rails. In modern steel lingo, it's 1084 steel. It's 0.7% carbon and 1.4% manganese. And so what they'll do is those will be melted off to the side in another little furnace in here, and then they'll pour that into here, and then they'll shake it back and forth and maybe turn the air jets on a little bit to get it all mixed up. And now you've got the proper components for the type of steel that they were making. And then, so that's all what happens here. And then they take and they pour it off into a ladle, which is held by this crane here, which is what you're showing here. And then they rotate it around and it's transferred to another crane that takes it to a casting area. And what they do is they pour it into a mold. And that's shown in this little picture here. There's actually a plug in the bottom of the thing, and they lift it up and they fill the mold with the steel. And then they let it cool for a little bit. And a little bit is like maybe 5 to 10 minutes, I guess. It's enough for it to be hard on the outside. So then they take it over here. They pick it up with a crane out of this casting area, bring it here, strip the mold off of it, and then they bring it here and put it into a soaking pit. And the soaking pit, so when the thing is coming out of the mold, it's hard on the outside, it's semi-liquid on the inside, and it's nowhere near even temperature all the way through. So they put it in these soaking pits so for the temperature to equalize throughout the ingot that's cast. And typically the temperature they want is like 2200 degrees-ish. And so that's what goes on inside the casting building. Now, when we look at this, okay, so all Bessemer converters are here, but we've got all these 4 things here and four more here. And what we're guessing here is that the soaking pits were separated from the Bessemer converter in the casting area. Don't know why. That's just a guess. But if it is that, and that's what our guess is, it's different from what Peter Kirk used at Moss Bay. And so we think that it probably represents some sort of an improvement that he came up with, because he was always looking for improvements in efficiency and whatnot. So anyway, we think that this was done differently. And because of that, then we think that when they moved up the hill, they probably kept this general design for the thing. And then what's next is the rolling mills. And so they take the ingot out of this soaking pit, put it on the mill, and they start going back and forth with it. changing the size and the shape of it each time they pass through. And I have some pictures from Peter Kirk patents of what some of his rolling mills look like. This is not the kind of rolling mill I think that they used, but it's one that we have a picture of. So essentially, you've got in the middle of it, you've got a series of rolls, and from the end, they look like this. And so here's how the ingot is going to be like 14 inches square, 4.5 feet long, and it probably weighs about 3,000 pounds. And so what they do is they run it through here. It reduces the size of it a little bit, and you can see each one of these is progressively smaller. And so what they'll do is they take and they'll run it through, and then they'll shift it over a bit, run it through again, shift it over, run it through again, shift it over, run it through again, until they've gone however many times they've got, rolling stations in here. And just as a matter of perspective, this is a gearbox that drives the whole thing. This gearbox is probably as big as the bedroom on your house. And these could be like almost a football field long. Pretty amazing thing. And then also from that Bessemer Steel book is a set of pictures, which I thought were kind of interesting, that actually show you how you get a railroad rail shape out of it. So starts just as your rectangle, and they start squishing it down to smaller and smaller sizes. Now the volume never changes. So as they get smaller and smaller cross sections, this thing gets longer and longer and longer. And eventually they start doing a little bit of work to form the flanges. And then after that, then they come in and they start forming the railhead. And when, after 14 or 15 steps, there you go, rail. And so that's what's happening in here. Now, this is a place that caused us some discomfort here. In the Anderson pamphlet, they talk about making the rolling out a piece of steel that's 5 lengths of rail long. But it's never explained what the length of a length of rail is. And so depending on when and where, you get different sizes. So in the time of this mill, the average flat car was 34 feet long. So the rails typically would have been 33 feet long, so they'd fit on the car. A little bit later in time, and not much later in time, they started getting 40-foot cars, and then the standard length of rail was 39 feet, so they would fit inside a 40-foot car. One of the people we talked to said, oh no, at the time of this mill, the standard length of rail is 24 feet. Well, remember, I can bring these maps in and I can scale them to full size. And I measured this, and it's only like 100 feet from here to here. And so it ends up like, what size rail do we use? Because 100-foot would imply a 20-foot standard length of rail. So when we finally decided is we're going to stick with the 34-foot flat cars and 33-foot long pieces of rail. So when we drew the mill up on the Rose Hill site, it's longer than what this is shown. Now, when you're done rolling it, it's still hot. Now, when it comes out of the soaking pits, it's 2,200 degrees. That's white hot. And to give you a little bit of reference, everybody knows the term red hot. Red hot is about 1,400 degrees. Orange hot is about 1,600 degrees. Yellow is about 1,800 degrees, and pretty much everything above 2,000 degrees is white. Now, so as it comes off the rolling mill, it's still hot. Now, Mike Intlekofer found some pictures of for us of a steel mill somewhere, and they had rolled this thing out and they were laying on the ground cooling, and they were still orange at that time. So we don't see an area here, or there's certainly nothing identified that suggests that there's any place where the rails would be able to cool off, but we think that they had to. And so when you get into this last building here, the kind of operations that go on in here, they'll cut it to length that now are, in our case, are 33-foot length. They'll deburr it. They'll straighten it if it needs to be straightened, and they drill holes in it. And if you're familiar with railroad track, there's a what we call a joint bar between the pieces of rail that where they bolt everything together and hold the ends in alignment. So they have to drill the holes for that. And it's my personal belief that with the metallurgy of the day, saws and the drills wouldn't be able to handle the heat, the yellow hot heat from that. So we think that or at least I do, that we need to have a cooling area. So when we drew the mill up on the top of the hill, I put in a cooling area. And then this building is a little bit hard to figure out what it is. It's got these feet on it. It looks like feet, I don't know. And our first thought on that was, okay, this is got a big giant gantry crane in here to move all these pieces around. And maybe these are the feet for the gantry crane. Later, we figured out that probably wasn't the case. And then there's a bunch of other stuff here for this mill that, okay, so like here is what we believe is the locomotive service, right? Because there's going to be locomotives to do all of this. Oh, Kent just sent me a message that says the internet connection is dropping. Can people still hear me? Anybody? All right, well, I guess I'll keep going. There's a bunch of other buildings in here. We don't know what they were. We do know, or there was some talk anyway, about the steel rail that got built in this plant being delivered by barge across Lake Washington through the ship canal. Now, as it turns out, the ship canal didn't happen till later. This mill didn't happen at all, so it ends up being moot. But we did cartoon in a little spur here over to where the lake is, and I guess it makes more sense if I turn the maps back on. Because here's the shoreline here. Now the other thing that was shown on here is the brick plant, and we showed the brick plant on that's up at Rose Hill, and it shows one here. And again, the whole purpose of this was to make brick for the mill, to either build or replace. So when earlier I had said that like a blast furnace would run for 7 years, what happens is the bricks get worn out and they have to basically turn it off and go rebuild it. And so this brick plant is making bricks to build the thing initially and bricks as replacements whenever they have to rebuild the furnaces and the stoves and ladles and whatever else they need it for. And so that kind of describes the steel mill. And at this point, I think what we had done is we had planned to stop and allow questions and answers. So, does anybody have any questions?
All right. Yeah, if anyone has questions, please put them in the chat. Chris, if you want to, we can also briefly unmute everyone if you'd like. If anybody would like to ask a question verbally, that's fine if typing's not there. If typing isn't easy for them to do on the device you're on. So Jack asks, we had LiDAR maps in the previous presentation. Where did we get them? Matt, do you want to talk about that briefly?
Yeah, those are actually available online through a variety of government agencies. Washington State and I think it's Department of pardon me, Army Corps of Engineers. I can get those links out somehow. Chris can help me figure out how we're going to do that. We could probably put them when we put this video up on our KHS YouTube channel, which I encourage you all to like and subscribe. I can have him put the links in there. That's a great question. But yeah, it's publicly available information. But I warn you, when you start going through it and zooming in on places that you know, you'll get sucked in for hours. It's really amazing stuff.
Yeah. King County IMAP also has that. If for people who've used that function, it's available as one of the background layers.
That's
So like the 1936 pictures and the more modern pictures that I've shown,
yeah.
have all been taken from the King County IMAP. And in fact, I have some LiDAR picture in there too, and that's also where it came from.
Jack
And the
says
nice
that-
thing about the IMAP is that their 1936 aerials are all stitched together. So when you get them from the map vault, it's just an individual section. But with the IMAP, it's got them put together. So it's a lot easier to use that way to look at the 1936 stuff.
Right. All right. So oops,
Anybody else?
wrong thing. Yeah, Chris was reminding me to turn my video back on. I forgot to mention to him that I can't turn my video back on. He can enable that for me though. So folks, you should be able to unmute yourselves now if you have a question you'd like to ask verbally. I don't see any more questions in the chat, so we'll wait a few seconds and see if somebody has a question before we move on. Okay, I guess we're done with questions at this point, and we can move ahead. Oh, wait, yeah. I see Jack popped up there, but he's muted, so I think we're good. I think we can continue.
Okay. All right. So now let's go see what I have in my file here. Yeah, that's too bad. I lost my other picture too. Okay. So what we're going to do is we're going to turn off all this downtown stuff just so it doesn't become a distraction. All right. So when it comes to this site then, well, maybe I should have left that on. What we were going to decided we were going to do is basically copy what we had seen from the downtown, because whatever it was, if it was different from what Peter Kirk used at Moss Bay, we think it must have been an improvement. When the railroad said no when they moved up here, one is we don't think they necessarily would have changed the design any, for one. And two, kind of suspect they probably didn't have the time to be too creative about reinventing much. So overall, the design kind of we think will look like a little bit what was downtown. But part of it was okay, so now where to locate all that. And so I will turn on the downtown steel mill again for a moment. So what we did is we assumed that this cluster of buildings here, the cast house, the rolling mills, and this post-rolling building, are all come as a group. And so the question is, well, where do we locate it? And so we had, like I say, we spent a whole bunch of time poking around in pictures, and then we started looking at the LiDAR pictures. And this is one of the LiDAR pictures. And you can see all these different features in it. All this stuff here is all the modern lots that have been graded. Not really sure what this is. It's coincidentally pretty close to where we located the sawmill. It's possible that maybe even the sawmill was mislocated. There's a round feature here, and perfectly round features tend not to exist in nature. Just doesn't come out that way. Um, and we wanted to look and see what was going on here, and it turns out, and I'm going to turn on this too, because I just to help highlight where stuff is. So it turns out that big rectangular area is a modern feature, and it's the parking lot for the Rose Hill Church. But that other feature, it's just out here in the weeds. There's nothing there, and there's nothing there in that picture, and nor is there anything in 1936. There's nothing here in 1936. And so we kind of thought that, well, that's a man-made feature. And since it's round, we thought maybe that would be the place where the Bessemer converters were. Now, typically at Moss Bay, his converters were in a pit because they have to be serviced from an elevated area. But this area here is down. Okay, I'm sorry. This is a CAD rail thing. This area here is downhill from where the furnaces would be. So it's entirely possible that what they did is that it's a little swampy here, that they made a foundation. They were going to set the converters on that foundation, and then you could, because it's below the level of this, then you just bring an elevated track in to and to get the iron to the Bessemer converters. So we had said, okay, we're gonna locate it here. And that's how we decided where we're gonna locate that stuff. And so the rest of the mill now, we're gonna start showing it to you in bits. You know that you have to expect that the area in here is going to look a little bit like the downtown mill. So when we broke this into phases, according to the plan, they had planned to build all the machinery for the mill on site. And that's what this cluster of buildings was actually all about. This essentially is the infrastructure to build the mill. Now they actually had a furnace in here too, in addition to the blast furnaces that were going to be there. There was a smaller furnace in here so they could melt the iron and make the castings, the pattern shop to make the patterns for the castings, machine shop and blacksmith shop to do all the finish work. But this isn't all the infrastructure they needed. The project went bust in the middle of what we called phase one, which is building the infrastructure to build the rest of the mill. And it went bust in the middle of that. And then the next phase is one we called phase two. And if you recall, they said they were going to build the mill in two halves. So they'd build one half of the mill, put it in operation, and then they'd build the second half of the mill. So phase one was building the infrastructure. Phase two is building the first half of the mill. Phase three is building the second half of the mill. Phase four is essentially steady state operation once the full mill is finished. And then phase five isn't actually a steel mill construction phase, but it's a recognition that as time went on, the capacity of the railroad locomotives got better. Remember I said that they could only get like one car up and down that hill downtown? Well, from here, for this spot, to get here, you have to go up a hill too. It's in Woodinville. It's a much less steep hill. It's only about a 1% grade. But still, the locomotives of the day could only call like 5 cars at a time per locomotive. And so we'll get into this a little bit later, but for this, typically we're looking at bringing 10 cars at a time up, so they would have to double head. Well, later, as the locomotives got bigger and stronger, and want too much later, you could get a locomotive that could pull 20 cars up the hill from Woodinville. And as an example, Northwest Railway Museum in Snoqualmie. They have the steam engine, the NP 924. That locomotive would be powerful enough to haul 20 cars up the hill from Woodinville. And that was only about 10 years after when the mill would have been finished. Actually, it was built almost at the same time. It was an 1889 construction. And by the time NP got it, it was, like 1904, 1905. So locomotives like that would have been available, 5 to 10 years after the mill finally got into operation. But anyway, so where we're going to do here is we're going to go through the mill and then in phases. So this is phase 1A, what got built. Phase 1B is the rest, finishing up the rest of phase 1. And so I'm going to start turning pieces on here. Oops, I don't want to turn that one on. I do want to turn this one on. Oh, maybe I do. Okay. And so now we start looking at what has to happen here. So the first thing they have to do in phase 2 is build the blast furnaces, build the first set of blast furnaces and the first part of the mill. So here, the blast furnaces are supposed to be in this area. And so we've got tracks basically to service the building of the blast furnaces. Over here, remember they said they were going to be coke ovens. So this is the furnaces in the main part of the mill are 1,500 tons a week is the capacity they could do. They can make 1,500 tons a week of iron. The little one in the foundry could do 30 tons. And so this is enough coke ovens to make the coke to run the furnace in the foundry. And so we've got a bunch of track running around. And so what they will, because they're making coke on site, what they're bringing into the bunkers here is coking coal. So then they take a load of that coal, put it up here into the coke ovens. And after about 3 days or so, that coke oven is done working. And then after that, after it's done, they spray it with water to cool it off. And then they would take it to, when the whole thing is running, they'd take it to a place where they'd lay it out on the ground, spray it down again to cool it off. And then they'd run it through a sorter so they could get the right size and store it in bins to be used. And so that part of that system is drawn here. So you'd have to start building enough pieces of the entire system to make the furnaces work. So you make your coke, you bring it up here, and then so when you're ready to use it in the furnace, then you just actually they'll have to bring it back up here and then dump it into the top of the furnace with this little track over here. And then the brick plant was here and it didn't have anything around it. The brick plant downtown has buildings of different sizes nearby. And some of the things that were missing from the brick plant are kilns. So they take clay, and they compact it into whatever the shape brick they want. Then they bring it over here to the kiln and they fire it. And then when they're done firing it, then you store it in a shed until you're ready to use it. Now, according to the one book I got from the Dean Freitag book, History of Making and Modeling of Steel, talks about the kilns. They're apparently about 30 feet in diameter, and they can hold 90,000 bricks. And as a matter of reference, the size of these sheds here, each one of these holds enough brick basically to build one stove. And then these guys, one could hold enough brick to make 4 furnaces, and you can extrapolate it out to get whatever you want. But so what they do is they'd make brick up ahead, and then when they started building a furnace, then they drive it over here on this. Remember I was talking about the railroad inside the plant. That's all in my world here. That's all maybe you can see it, dotted lines. And that's what this is this narrow gauge in-plant tram system to move material around. And then a little bit of stuff to service the tram engines. They need the steam engine in here to run the molding machinery and to run the furnaces here for the kilns. There's a coal bunker, and that's serviced by the railroad out here. And then I also added in a building to bring the clay in. So you bring a string of flat cars in with clay, and apparently it comes in barrels. Um, on the in the as-built section, they actually imported 2 shiploads of materials from England, which include a bunch of bricks, and we'll talk more about that later. And fire clay, which is used to make the fire brick. And it was delivered because we had, remember, we talked about having the freight bills for the Seattle Lakeshore and Eastern, and it showed that being delivered in flat cars. So we're assuming that the clay came in barrels. So the thing here is the tram system comes over. You could load a bunch of barrels on it, bring it into here. When the barrels are empty, you bring them back and put them on the cars. And so over the period of like a week or so, you trade out a train cut of cars carrying loaded barrels to a cut of cars with empty barrels. So that's phase 1B. With that, you have enough stuff to start making the machinery for the rest of the mill. Now you have to put up a bunch of buildings, and that's okay because while they're building the buildings, that they can make the pieces for the machinery so they don't have to wait too long. So that's kind of what it looks like for phase 1, phase 1B. And a lot of some of the other things that we did in here, if you recall, the siding for the railroad here was only 1,500 feet long, but the NP maps showed it being almost 4,000 feet long. So we grew it back to its original length and used that to branch off to get materials over to here. And I guess this one's a little bit out of place, but so the sawmill is here. And if you remember the sawmill, they were logging the site to get wood for to make the buildings. Eventually that would run out, and so there was had put a siding in here for the excuse me, put a siding in there for the sawmill. I think I'm kind of taking too long here. Okay, so now phase 2. Here comes phase 2. This stuff is all what you end up needing for phase 2. So you build the first half of the mill, and that's all this and this, right? So here's arranged, not unlike what they showed downtown and what Peter Kirk used in Moss Bay. Blast furnaces and stoves behind it. And then here's the tram track that comes to this lift system that hauls the material from the ground level up to the top of the furnaces. Here's the casting house with the Bessemer converters. And if I come back here to the LiDAR picture, you can see that circular feature is underneath there. That's how we located that. No more science than that. There was an article in an English newspaper. It had a longer name. The last part of it was Keswick Guardian. I refer to it as Keswick, that described the Moss Bay steel mill. And they talked about having a laboratory where they checked the quality of the material. So I threw a laboratory in there. Here's your soaking pits. Here's the rolling mills. Now downtown mill, they only showed one rolling mill, but running the math on this thing, they basically have to roll out a piece of rail every 5 minutes here. And this thing is 170 feet long from here to here. That's how long the finished piece of rail was. And it just seems hard for me to believe that you could essentially take 7 or 8 rolling steps through here and 7 or 8 rolling steps through here and be able to get it done in time. So I put an extra set of rolling mills into each half. Whether that's right or not, who knows? And there's a lot of empty space in here, but there's really not. So remember, this is that gearbox. Not shown in here is a giant steam engine that runs the gearbox, and then a whole bunch of other machinery that would shift the rail between all those different grooves in the roller. And again, we added this area here. They lay them out on the ground to cool. I have no idea how long they take to cool. We picked a number and said 8 hours. And then it comes into the building at the end where you cut it. You bring the material after it's cooled, you slide it in here on a set of rollers, cut it off into your 33-foot lengths, and then deburr it straight, drill it. And then when you're done, over here is a standard gauge railroad track with flat cars, and you just take a crane and start loading them onto the flat cars. And in my world, it was 100 pieces of rail to a 30-foot flat car. And it comes out just right at 30 tons because 30-foot flat car is about 30-ton capacity. So that's your rolling mill. And then threw in the slag pile. So slag has commercial value. And so what they did is they bring it onto an elevated area, typically just a bank of dirt, and they dump out the car and it cools. And once it's cool, then they can take and they can do things to it that they can then sell it. And so typically what they'll do is they'll crush it, grind it up, and depending on how fine you grind it, you can use it, for example, as railroad ballast. You can use it as aggregate for concrete, asphalt, roads, whatever, depending on the area you're in. Now, what Jim Swinkendorf told us was that in the modern slag areas, I mean, they typically collect the material with a front loader, drive it over to the crusher, and then as they fill up the hopper cars, then the front loader will move the cars along. So that way they don't have to have a switcher engine standing by all the time. Now, of course, in this time period, you don't have front loaders, but they did have steam engines. And the early steam engines were on railroad wheels. And it wasn't until the early 1900s that they started being on Caterpillar tractors. So the assumption here is that the track nearest to the slag pile is the steam engine on railroad wheels. They could be self-propelled still. So you would dig it up, put it into a set of cars, push it over to the crusher, and then the crusher would fill it, and just like Jim had described for the modern mills. And again, you just have a cut of cars here, and you bring one in front of it, load it up. There's a winch, steam winch down here with a cable. Or you either pull it along with that, or you pull it along with a steam shovel to move one car to the next. And so that's phase 2. So once this is done, you can start producing rail in this half of the mill and start building part 2 of the mill, which looks surprisingly like the first part, just more of it. And so now you get the second half of the mill. And again, you've got railroad cars here, so when they're loaded up with rail, then they come off the back, the bottom here, and up into the yard, and then off to wherever they go to. And here's where the interesting part is. Now that you have all this, we go back to, oh yeah, I didn't talk about that. Let's talk about that real quick. So this is what 800 coke ovens look like. And each one is served by 2 tracks, and that's what this picture is. This is where's Wilkeson? It's in Washington State somewhere. There was a coke works there, and this is what it looks like, where they're kind of built into the side of a hill, and there's a track below and a track above that look like this. So the bottom one is where when it's done, you scoop it out into the car. And the track above is where you tip a load of coal into the coke oven to be turned into coke. So that's what all this is. All this in here. I apologize for forgetting to show that to you. But it's 800 coke oven. That's a lot of coke ovens. Now, where I was going to go with this is this. So now we come back to this picture. And it says, well, what did we make it out of this picture? Well, if I look at that picture, and remember, I'm looking from down here. It's very, very close. So I'm looking here at all of this, and it makes more sense now. All right. So this building down here is a rolling mill. This building going crossways, just like it did downtown actually, is the cutting and drilling area. And those things that I thought were feet for a gantry crane, according to this smokestack coming out of it. So that's either a boiler or a boiler and an engine to provide the power to run all the equipment that's in this building. All of a sudden stuff makes sense. And then an office building, because you got to have offices to run the mill. And so it turns out that I think this picture is actually a pretty reasonable representation for what the mill would have looked like, which is kind of cool. Now, I kind of talked about the brick plant here again, and we had some more that we wanted to talk about the bricks. And so are you ready, Matt?
Sure.
Okay, so
So,
what do you want me to show first?
uh, do you have the French photo that showed the one and only photo we have of the brick facility that was actually constructed?
Yeah. Okay,
Okay, so yeah, perfect. So this is off to the west of this main mill site area that Mike has been talking about. And of course, you saw it on the diagram. It would be roughly where about 405 is today, wouldn't it, Mike?
yeah.
Or right up near it.
Yeah,
Uh,
that's actually a picture I'm going to show later, but I can
just so people have sort of a
just throw it in here right now.
perfect. Just to give everybody a little bit of a chance to sort of pin down, where all this is in 2025, Rose Hill, Costco area.
Yeah. Okay. So no, just keep telling me what you want me to show and
Oh, okay. I'm sorry. I thought you had a picture of where it is now relative to 405. Is that
yeah,
it on
that's
there?
that's that's it here. Maybe
Oh,
maybe
okay.
what
So
I
yeah, yeah,
should
yeah. I'm sorry. I didn't see it there on my screen. So it's approximately about where the Costco gas station is today, which you see right there by Mike's cursor. So just to give you an idea of where that was, but they built this brick plant, which was for the manufacturer of fire brick, a refractory brick. That is to say, a special type of brick that can be used with high heat. And that was going to be used a lot throughout this process, from inside the stoves to the inside the Bessemer converters themselves. They had a lot of use for that, which is presumably why they wanted to be able to make it on site. And fire brick is a bit more difficult to manufacture than your standard red type construction brick. They did have an additional brick plant that was located down a lot closer to Lake Washington. And it is from the brick that was constructed in the area of what is now downtown Kirkland, that was used to make the iconic 1890 vintage brick buildings from the what was going to be the downtown for the steel mill at the intersection of 7th Avenue and Market Street. So the classic, iconic Kirkland Arts Center building with the cupola and the Masonic Hall and the Sears Bank building. Those were all built as part of the Kirk boom with local red style construction bricks. So when we saw this picture in the French photograph, and again, for those who weren't here before, Harry French was the pioneer Houghton resident photographer that went up there with his wooden box camera and took a bunch of shots on glass plate negatives. We were really surprised to see this, and we had to do some digging to kind of figure out what was going on with that. And I think Mike has pretty well explained why it was so far out from where the rest of the stuff had been. So refractory or fire brick came in a variety of shapes and sizes. Here's an example. Can look like just regular brick like this. This is one I found it diving in Lake Washington. That's kind of another story. It was out by our friend Harry's house over related to the Newcastle side of things, that part of Lake Washington.
Oh,
But there was a lifelong, wonderful man who'd been a long time member of Kirkland Heritage Society named Dr. Ernie McKibben. He was the junior, however, and he practiced medicine in Kirkland, through the 20th century. But his dad, Dr. Ernie McKibben Sr., had practiced medicine in Kirkland in the first part of the 20th century, including in World War I. So that's well before the Sullivan brothers. And so they would, conscript guys or have enlistments, and they put everybody from the same general area often in together in a unit. So you had a lot of these guys in Kirkland after World War I who had served together in the war. And as a matter of fact, the American Legion Hall in the interwar period was kind of the de facto Kirkland Town Hall, because that's really where all the decisions were made among the veterans who mostly ran the town. But Dr. McKibben Sr. had been the doctor for a lot of these guys in the Army. So many cases, he was bringing Kirklanders into the world. He was patching them up when they were shot up in France, and he was a fascinating guy. But he had gone up to the mill site and collected some fire brick that was used in the family home when Dr. McKibben Jr. was a little kid, in their garden area, as pavers. So I think it was in either the 1990s or maybe the early 2000s, Dr. McKibben Jr., of course, by then his dad had passed away, came in met up with our collections lady and board member, Loida, and he gave her all these fire bricks and told her the story about where they'd come from. So we were delighted to get them, but it was puzzling because of their shape. They're a lozenge type shape, as you can see in the photograph there. They're not your standard configuration, brick looking brick. So in trying to research this, these things were in there for a long time, and never really looked into it that closely. But as all this started coming up, started digging into this, and we finally were able to figure out that they were a sort of proprietary design fire brick tile that went inside this Ford Moncourt stove that was that Mike has discussed, that was part of the process, for the steel manufacturing, and they would have had very limited use other than that. And I went by a KHS today, and I went by a little earlier. I forgot the open hours, and I was going to ask Loida if I could borrow one of these, and she wasn't there, so maybe I'm in trouble. But I've got one here to show you on the camera too, just to give it a little scale with me holding it. And I'll put it back tomorrow after work. I'll stop by. But this is what they look like. And as soon as I saw in the diagram that sort of lozenge diamond shape, it was a eureka moment, like, aha, that's it. And then sure enough, through later research, once we knew some keywords to search out, we were able to find out that this Ford Moncourt stove was what was going to be used there at the Great Western Iron and Steel Company mill. So that was a fun little mystery for us to solve. And in the process, we learned quite a bit about fire brick. As Mike had mentioned, the initial loads of this stuff were brought over by ship from England, and they had various forms of fire brick, as well as what was called fire clay, which was used in other parts of the process. They had freight car after freight car of this stuff brought in by the old Seattle Lakeshore and Eastern Railroad. That rail bed from Seattle, by the way, is what is now the Burke-Gilman Trail around the north end of the lake. And that went down into Woodinville and then came up the Lake Washington Beltliner, that of it which was constructed up to Kirkland. And I would just add real quick that a good friend of Kent's, a man named Dan Cozine, who is a human encyclopedia of all things Northern Pacific Railroad. It's just amazing how much this guy knows about this kind of stuff, and has had a lot of hands-on experience with steam locomotives. He told us that because of the grade originally between Woodinville and Kirkland, that he thought one of the directions the locomotive would not have spun around. It would have had to back up the hill to keep a particular angle of water in the boiler, because if it was the other way around, the boiler would get so hot that it would explode. And that was a problem in locomotives as well as steamboats. Boiler explosions were like a common thing that used to happen. So in those initial stages, the trains running into Kirkland would have backed up the hill from Woodinville, according to Dan. But a bunch of this stuff was brought in. A lot of it, as Kent mentioned last time, was brought across the lake, and the company had constructed a warehouse down at the foot of Market Street. But that's just kind of a little bit of an overview as to how these ended up in Dr. McKibben Jr.'s childhood backyard with their kids playing on them as pavers for several decades. So I'll throw it back to you, Mike.
Yeah, we can keep going on that a little bit here. So this is the patent picture for the Ford and Montcor stove. And this is a section, you can see the lozenge shaped bricks here. And if you look at it, this is looking down through it. And what it is it's all brick, and it's just nothing more than a bunch of passageways. And when they use the stove, what they do is they burn and they heat it up, all this brick up, they heat it up, and then they blow air through it. And then it gets hot and goes into the stove. And while they're doing that, into the furnace rather. And then when they're doing that, they're heating up another stove so it's ready once the first one cools off. But you can see all this work in here. You get essentially what is a solid wall of brick here, and horizontally here, that's solid brick. Like you just stack them on top of each other like a wall. And these pieces here, these vertical bits, that is these lozenge shaped bricks. And get back to the picture here. Looks like that. So the gray is your wall of brick, and then these guys are those bricks that we just showed you the pictures of, and they're that shape to make them aerodynamic because the air flows through it up and down, and that's why they're shaped the way they are. So the combination is they help pick up the heat, but they also hold the walls apart and make the passageways. And it's kind of interesting. Okay, so I want to go back here. I apologize for having all these manipulations. It's necessary because I would have to jump from one share to the next in order to show everything. Okay, so let's get rid of the picture. And then I'll finish talking about the last of the stuff here, and then I'll turn the picture back on again. So the last thing that we had to do is imagine what the yard would have looked like for the Kirkland yard that served the steel mill. And so we came up with this. And I'll explain a little bit about it. And let's remember, we're talking about it, the early on steam engine could only bring 5 cars up the hill. So if you wanted more than that, you had to double head. You have two engines. And so you bring 10 cars at a time up. And so I actually sat down and worked out for the raw materials how much they needed to bring in, and and actually came up with a schedule for what the train, how many trains it would take. But simplified, it looks like this. And this is when both sides of the mill running. So okay, I'll just have to not touch it. So this is an example of all right, hang on once. No, okay. This is anyway. So you'd have 48 hopper cars full of iron ore every day, 30 flat cars empty that they'd load up with rail every day, 20 hoppers of coking coal. For the the yard assumptions, we also assumed that eventually the site would be logged off and they'd have to bring in more logs by rail for the sawmill. Now, at some point, the sawmill is no longer needed to make wood for the steel mill. In fact, probably about the end of phase 1, it probably wouldn't have been needed that much more because most of the rest of the buildings were to be brick. But anyway, the idea is that the sawmill then could either continue making some things for the mill, and it did need to do that, but it could also be used for other commercial uses. And in fact, later, after the mill went bust, they started making shingles at that site. So somewhere between lumber and shingles, so you bring in a bunch of empty cars so you can haul out the finished wood. Um, Bring in some empty cars to carry away the ballast, slag ballast. Every other day you get 7 hoppers of limestone. Every week you get fire clay in barrels and thermal coal. And then whenever they needed it, single cars with whatever miscellaneous stuff it takes to run a steel mill, you know, spare parts, rags, oil, you name it. And all that would be like 140 cars a day. So that's a fairly busy place. And the way we envisioned it working, uh, the scale of this is still too hard to kind of really show. Is this extra siding that we added back in, that becomes the arrival track. So a train coming from Woodinville would come up and it would drop its load here. And then the locomotives would come down into the yard and then come back up here. This is a locomotive service area for the switchers, but it's also available for the road engines. They could get more coal, water, whatever they needed. And then they'd come back down here. This is the departure track. And they'd pick up whatever loads are ready and take them back to town. And in the meantime, a switcher would come and take these cars, deliver them to wherever they needed to go in the plant, and either bring back outgoing loads or empties and stick them on the departure track just in time for the next train to come in from Woodinville for its locomotive to come and pick the stuff up. So that's kind of how the yard was meant to work. And so as it turns out, you could run the whole yard with just the arrival track, the departure track, and just a couple of shorties over here to catch all the stuff that doesn't come on a daily basis, where you might have to store a few cars in the yard. And then the rest of the tracks are essentially spares, right? Because if you ever had some kind of a hiccup, you'd have a 10 or 20 car train show up and you need to have a place to put it. But it actually worked out that you could run the whole thing off of the one departure track, because the outgoing locomotives would come and pick up all the loads and empties and haul them away just in time for the next one to come. And so it would work out. But that's the yard and what I drew for the yard. And that then is the whole steel mill and kind of how we got there. And so now what I'll do is I'll go back and I'll turn the picture on just so you can see where it all is. Oh, okay, hang on a minute. There. So the rolling mills and the trimming areas run into the Costco. I didn't know this was a Costco gas station, but the brick plant is up here. The slag pile is in the Costco parking lot. These guys are all going up the hill behind the bunkers. And so that's how we got where we got.
That's wonderful, Mike. Yeah, the hill where the coke ovens are, assuming that that's kind of a built-in feature that you kind of want them staggered like that, it was probably no accident that they placed them there, because there was that fairly steep hill on the east side of the property. It's still there today behind the shopping center that has a variety of restaurants and things in it.
Yep. It doesn't have to be uphill though. There's plenty of pictures of the coke ovens just all in rows.
Okay.
But then you have to have a ladder or something to carry the material up to the top to dump it in.
Right. So it's convenient for it to be uphill.
Yeah.
All right. Well, I think Sandy's going to join us now.
Okay, so I will stop sharing so Sandy can do her thing.
Yeah, and I'll reshare, and Sandy's going to bring it home for us and kind of close out kind of the context for where this was all happening and what happened after, from what she's researched about Peter Kirk. So I'll reshare the slides. All right, Sandy, take it away.
Well, as Mike said, the plant went bust early on, and the trouble for Moss Bay Enterprise started soon after really getting started. In the summer of 1889, fires swept Seattle, destroying much of the downtown area. Many local investors found themselves caught up in rebuilding Seattle, prompting Kirk, Hunt, and others to reorganize the corporation into the Great Western Iron and Steel Company. This brought new names to the project, which helped fill the gap from the waning influence of Kirk's England ironworks. Moss Bay of England was struggling, and its focus and funds were concentrated closer to home. Attention from Washington, D.C. had also retracted. The new administration had different priorities and an agenda that didn't include the canal connecting Salmon Bay to Lake Washington. The financial panic of 1893 constricted American investment even more. Overextended financiers defaulted on their investment promises to the Kirkland steel mill. As the crash swept the nation, banks failed and railroads went into receivership, including Seattle, Lakeshore, and Eastern, and Northern Pacific. Struggling with trying to meet basic operating costs, building a rail line to the Denny ore deposits was out of the question and sent a crushing blow to Kirkland's ironworks. The Kirkland steel mill filed bankruptcy, and the equipment Kirk had stockpiled was sold to pay debts. With no work at the mill, employees moved on to find other work, as did some of the directors. Walter Williams moved to Seattle. John Kellett found work for a few years at an Eastern Steelworks, then returned to Seattle. William Anderson found work around British Columbia, then settled in Vancouver, BC. Lee S.J. Hunt went to Asia, leaving his father-in-law, Henry Noble, a director for the steelworks at Yarrow Point, to handle the necessary business in his absence. Peter Kirk and his family also remained in Kirkland, buoyed by his wife's inheritance. His enterprising disposition and inventive mind sought other ways to make a living. He and other Kirkland citizens invested in a local ferry service on Lake Washington. The Yukon Gold Rush brought a lot of attention to Seattle, and Kirkland benefited as well. Stampeders stocked up on wool blankets and clothes supplied by the local woolen mill. Kirk got into the act by registering a patent for a dredge that could be used in the gold fields as well as dredging canals. It seems he still had that ship canal in mind. Others were working on restarting the mill around the turn of the century, including John Kellett. We don't know the extent of Kirk's involvement beyond math calculations in a small notebook concerning scrap iron and a short statement in a Yakima paper where Kirk stated some friends were looking into it and wanted him to come see. He seemed leery from his past experience, but said his hopes were buried in the womb of the future. Kirk developed a patent for crucible steel, but it was never registered. There is no way of knowing if it was meant for the original mill or later plans. He also registered another patent for replacing the standard coke fuel with crude oil in a smelter for refining minerals in conjunction with a partnership in Arizona. Peter Kirk's high regard and lifelong expertise with integrated iron and steel mills set him apart in the industry. He was asked to consult on projects in and around Washington. In 1903, after a series of fits and starts, the Irondale Foundry in Port Townsend asked Kirk for a detailed report on what was needed to get that ironworks running again. Likewise, other steel industry companies sought his in-depth knowledge of the ores in the area. Even though Kirkland's Great Western Iron and Steel Company was shuttered in 1893, there was still a lot to be done to unravel the corporation. Equipment had to be sold to pay debts to the Kirkland Land and Improvement Company and others. Lawsuits had to play out to tidy up the permits, licenses, and other loose ends. All the while, Kirk and his family continued to live in their home in Kirkland. However, the tragedy of his daughter's untimely death in 1904 pressed them to move to their summer home on San Juan Island, where Peter owned a large sheep ranch. Kirk often traveled to Seattle area to visit friends and conduct business. Peter and Mary Ann continued to own a significant amount of property in Kirkland, including Fir Grove. He was still involved with the town site acreage as well. The team at Burke and Farrar became interested in the town site, and a deal was struck to cash Kirk out in 1910. Kirkland entered a new phase of its development. And this coincided with renewed efforts to build the Lake Washington Ship Canal. Kirk watched the process in his waning years, possibly with a mix of emotions, such as satisfaction that it was finally being done and uneasiness that it hadn't happened in time to save his steelworks. But as he suggested to Burke and Farrar's manager on the prospects of Kirkland and the east shores of Lake Washington, Kirk envisioned a bright future for the area. Peter Kirk probably read about the progress of flooding the canal locks in February 1916, which opened the ship canal to traffic, but he wouldn't witness the official celebration the following year. He had lost his wife a few years before the Burke and Farrar deal. His English compatriots and good friends Walter Williams and John Kellett had also died. His health was declining. His children were out on their own, and the grand house at Deer Lodge might have seemed lonely. In 1914, Peter turned the Mitchell Bay Sheep Ranch over to his sons and had a small home built in Friday Harbor near his daughters. He died there in May 1916. The canal was so pervasive in his thoughts and plans for Kirkland that even in his final hours, he told a friend that he could leave his friends confident that his predictions concerning the country across Lake Washington would soon be fulfilled. Even though the Kirkland steel mill never produced any steel, the extent of the project prompted Eastern industrialists and financiers to turn their attention to the West Coast frontier. Railroads laid more tracks, Washington's resources were mapped and measured, and the population grew with job seekers from around the world. This in turn led to even more growth for the burgeoning state.
All right, that's wonderful. Thank you, Sandy, for bringing the context to what happened afterward. It's what a guy Peter Kirk was, and all of his family, and staying involved in the area for generations. All right, so this was a fairly lengthy presentation, but if there's anybody still with us who has any questions, we can take those now. Otherwise, we'll bring it to a close. Oh, hi,
Hey,
Mike.
Mike.
Hello. I have an observation, Kent, if you want to hear it.
Well, we all would, I think.
I see. Well, when I first heard about Peter Kirk and the whole steel mill activity, I always wondered, was he a scammer, or did he make a half-hearted attempt at it, or was he really sincere in his effort to build the steel mill? And after watching you guys do all the research, reading Sandy's book, and seeing how much equipment was brought out and tonnage of bricks that were brought out, it was pretty clear that Peter Kirk was sincere. He was competent, but he was just the victim of circumstances. And, to make that mill work would take about 10 things going right. And he had about 3 of them going right, but 7 of them went bad, and it just collapsed. And so I learned a lot in this whole process.
Well, thank you, Mike. Appreciate that. All right, any other questions from anyone? If not, we'll bring it to a close and wish everyone a good night.
One just really quick last thing, Kent.
Sure.
Mike asked me to identify the source of an early on in the presentation photograph of some homes in Kirkland. And I'm terrible about citing sources on photos, and these archives, the people in these archives are so helpful to us, and we like them so much that I just want to give a shout out on that to Puget Sound Regional Archive. Those are the King County property assessor files, photographs taken from the late 1930s, and then periodically up to the more modern era. And that's located at the campus of Bellevue Community, or now it's just Bellevue College out in Bellevue. They can help you by appointment if you have a particular property that you want to look at the old photos of. And again, the archivists out there just it couldn't be more helpful. So I wanted to make sure we got that as part of our recording.
I'm sure glad you did, because I just had email from Midori Okazaki today, the lead archivist there, and she's going to be watching the video. So you would be getting a nasty email from her, I'm sure, if you didn't mention that.
I don't want to make her mad. I heard she's going to retire, unfortunately.
All right.
I did have one little comment on the bricks. Something I read through the Bessemer and the steelmaking stuff. The bricks could be made to be acidic or basic. And depending on what you were doing and the type of raw materials you were using, you would either want it acidic or basic. So, for example, the Bessemer that Kirk used in Moss Bay was acid brick in his Bessemer converters, and it also makes a difference in the blast furnaces. And so when they talk about modern stuff, and they talk about the basic oxygen process, they're talking about basic as in alkaline bricks.
Yeah.
Not as in a simple oxygen process, but actually alkaline bricks.
And Rob, I see you turned on your camera. If you have anything you want to say, feel free. Otherwise, oh, you're muted there, Rob. Yeah, you're muted. We can't hear you. I think Chris enabled everybody to be able to turn on their mic. So looks like you're looking for the microphone icon on your screen there. Should be down at the bottom left on most devices.
There you go.
There
Sorry
you go.
about that.
Hi.
Yeah, I just want to say I appreciate you folks putting the presentation together. It was very informative. Good job.
Thank you for coming.
It's been off and on for 8 years. We've been working on this a long time. And it really has been a dream team of people to work with. A lot of unique skills that blend together really, really well. So it's been a delight. Friends of mine, Bill and Jan Taylor, talk about in historical research, usually what you get, the pieces of information you find are kind of like flash bulbs in a dark room. So you kind of see a little bit about what's going on, but you don't get the whole picture. Good metaphor. Yeah. But we just dug and dug and dug. And so I think the lights are on a little bit and kind of flickering. It's a little bit better than flash bulbs, I think. But yeah.
I like to think of it as building a jigsaw puzzle without a picture and half the pieces missing.
Yeah, that's about right. That's about right. All right. Well, thank you, everyone. And again, the video will be available soon on the Kirkland Heritage Society YouTube, and we'll be sharing that link. Really appreciate your time tonight. Thank you.
Thank you, everyone. Good night.
Thank you.
Bye-bye.